Good morning or good afternoon, everyone, depending on where you're joining us from. My name's Georgia, and I am Head of External Comms at Fluke Reliability, which is home to eMain and Proof Technic. We've got a truly special webinar today. Our speakers are Christian Silvernackle and Gavin Robinson, and they're going to talk to us about connected reliability in the automotive industry. Firstly, we've just got a couple of people logging on, so I'll just give them a second, and then I will introduce them and we can get started. You can see the numbers going up slightly. Cool, I think we're ready to go, and then others can join in when they join in. Thank you for joining us for today's webinar titled Connected Reliability in the Automotive Industry. As I mentioned, our speakers today are Christian Silvernackle and Gavin Robinson. Christian is our Strategic Enterprise Account Manager at Fluke Reliability, and Gavin is our Key Account Manager for Automotive. Before I formally introduce them, I'll cover a couple of housekeeping topics. So today's webinar is being recorded and we will share a link with you after the event. You'll also be able to find it on the Fluke Reliability YouTube channel. So if you'd like to revisit the content or share it with somebody else, please do after the event. As always, we also invite your comments and questions. So you'll see a Q&A chat box on your screen. And if you think of a question for the speakers at any time during the webinar, please just type it in there and we will pose it to them at the end of the event. Perfect. So I will introduce today's presenters now. Christian is passionate about delivering value in the predictive maintenance and reliability space with over 10 years of experience in engineering and customer-facing roles. He serves as strategic and enterprise account manager at Fluke Reliability, supporting customers on their journey to connected reliability to enable them to fully unlock the potential of their maintenance and reliability programs. Gavin has been working in reliability for over 7 years. He helps customers streamline their maintenance processes and increase the uptime of their critical assets through the application of eMain. In 2022, Gavin moved into a new position as Key Account Manager for FRS Automotive customers, so very fitting for today's webinar. Thank you so much for taking the time to present today, guys. With that, I will hand over to you for today's webinar.
All right, thank you very much, Georgia. Welcome everyone to our today's webinar around connected reliability in the automotive industry. Georgia gave a brief introduction for ourselves. So I'm Christian Silvernagel. I'm Strategic Enterprise Account Manager at Fluke Reliability. Been in the field of maintenance and reliability now for over 10 years. Started out as online condition monitoring engineer back in the days. And in my free time, you're gonna find me outdoors camping and hiking. Turning over to Gavin.
Thanks, Chris. My name is Gavin Robinson. So as Georgia mentioned, Key Account Manager focusing on the automotive industry for our customers. Been in the industry for 7 years now with a particular focus on our CMMS solution, eMain. And similar to Chris, I like getting outdoors, traveling, and also sports. So today for the agenda, so obviously introduction's done, we're going to be covering some of the obstacles that automotive companies are facing in the industry, some of the trends we're seeing, some of the insights that's brought us, and then how can we transform those insights into findings? How can we take action and then bridge that gap? And then at the end, we'll give you an opportunity to ask any questions, which we can hopefully answer. Next slide. So Fluke Reliability, so we serve over 70,000 customers all over the world on their reliability journey, 24 offices, 700 employees within the group, covering a variety of solutions from CMMS EAM to laser shaft alignment to series of solutions where we help and serve our customers. Next slide. So some of the changes that we're noticing in the industry for automotive companies. So I suppose first of all, we have seen a growing skill gap. So a lot of companies in the automotive sector are having to find skilled workers to replace those who are retiring in the next few years. Stats show that more than 25% of manufacturing workers today are over the age of 55. So it's a case of passing on that knowledge to the next generation. Also, manufacturers are investing heavily in the space of digital transformation, IoT, especially in relation to AI. And we're seeing that maintenance and reliability teams that are adopting IoT are gaining a competitive edge in the market. As you can see, that's at the bottom. So manufacturers are investing $524 billion annually in digital transformation initiatives, all looking to get a step ahead. In terms of, this is just highlighting the need for, connected assets, people, and systems across, these companies. Reshoring, so due to costs, quality control, shorter lead times, we're seeing a lot of businesses that are bringing back operations to HQ. And then a big focus has been the environmental side. So you'll see with a lot of companies reducing carbon footprint, rising in electricity, gas prices. All these sort of elements are leading to a big focus on sustainability and environment. And over to you, Chris.
All right. And how can we now actually address those macro trends that Gavin was mentioning, right? So basically, with a reliability solution that includes measurement tools and sensors, alignment systems, intelligent software, and services, while managing the maintenance workflow and execution. And by combining all these workflows under one roof, that delivers an unprecedented time to value for organizations. And then also breaking down the silos of hardware and software, that is what enables organizations to shift from reactive to proactive maintenance, because there are still over 60% of organizations out there that are still going for a reactive maintenance approach. And there are truly benefits, right? So there are benefits like accelerated time to innovation, better efficiency, increased uptime, breaking down those operational silos that I was mentioning earlier, highlighting energy consumption and the energy consumption, and improving worker safety. And connected reliability in here, that is really a true framework that combines the hardware and the software systems from across the enterprise into one cloud-based maintenance ecosystem. And for those that have been attending our webinar, the 5 pillars of connected reliability, that is what should illustrate and help you to break down the topic of connected reliability in a more easier to digest way, right? So what we are seeing in the background, that might be very familiar to some of you, right? So we have the asset health, right? And then we are seeing the asset health deteriorating over time. So once a failure is introduced into the asset, we can see it deteriorating. And then we have different modalities, different technologies that we can apply to actually observe the asset and actually walk with it and see how it is deteriorating over time. So there is technologies like thermography, vibration, ultrasound, oil analysis that we can actually use. And now let's have a look. So first of all, the first very important pillar of connected reliability is the install phase, right? That is the install pillar. This is where you would use alignment systems to precisely install your asset, because that is the point that allows you to push your asset as far to the left as possible on your PF curve. And this basically is setting the stage for your asset, because up to 50% of the failures on a, or let's say secondary failures, we should actually say so, are coming due to misalignment. The next part, the acquire pillar, so creating connected data. And when we're looking along the PF curve, we are seeing all those different modalities. So what is the best technology or modality to actually observe my asset and gain further insights? And then how do I bring that into context with information that is already available in my automation and control systems? And then after that, we're taking this newly acquired data, and then we want to enrich it. So then we have the pillar of actually enrichment. So here, condition monitoring data, because you have to think by itself, is not complete. So it doesn't know when an asset was last serviced, or what actions were performed, or when maintenance is next due, right? and it doesn't know the asset history of failure, what parts are needed to complete specific jobs, and whether those parts are on hand. We're going to hear from Gavin later on then how we take this enriched data set and transfer that into actions. So how do we create connected teams? How do we effectively communicate through different layers, and then also through all the teams, horizontally and also vertically within an enterprise? And then the last pillar, connected knowledge services. It's actually kind of an overarching supporting pillar for the first four mentioned, because connected knowledge services, as we heard from Gavin, there is a skill gap in the industry, and there's being predicted that there is a skill gap of up to 9 million workers in the coming years to be expected. And for connected knowledge services, we can actually bridge that gap, right? Helping out in the installation phase, also identifying what is the right system to acquire, but also bringing in the experts to bridge the gap on the entire reliability journey. Right, and with that, I turn it over to Gavin.
Yeah, just to cover some of the obstacles really facing the automotive industry. So I suppose one area will be a surprise to no one how heavy supply chain dependent it is. Obviously, the global chip shortage, which hit the industry badly in the last couple of years, difficulties in transportation of cars overseas, lack of components and parts. As well as that, there are many dynamic applications to utilize. Which ones should company focus on to adopt to get ahead? It is a very competitive market. We've seen, with the introduction of electric vehicles, more and more companies are trying to get ahead in that regard. In 2021, 10% of cars sold globally were EV, electric, highlighting how we're seeing a big change in that regard. And then also around high energy costs. So the rise in the price of electricity and gas represents a significant increase in the costs for automotive companies. And that's why they're trying to find ways in how to kind of, solutions for that. Moving on to some of the common pitfalls that companies face when they're introducing new solutions, siloed implementation. So the gains made by, certain departments, locations within a company are not being shared. There's a lack of standardization, so companies aren't seeing the true benefits on a larger scale. Pilot purgatory, so where companies are pouring resources into projects that don't go anywhere after the initial deployment. So, and that could be due to data silos, conflicting requirements, limited resources from a company's perspective. The one-size-fits-all approach. So if a solution is not adaptable, flexible, that's going to force your processes and workflows to change, even if they are working. So you're trying to shoehorn into particular solutions, and then prioritizing technology over value. So where there's too much focus on the rollout of a single product, whereas possibly a mix of solutions, a mix of sensors, tools, and a solution, a CMS EAM solution may see a larger benefit. And over to you, Chris.
All right. And now let's talk about how we can create insights, and also probably what a lot of you guys are looking for. Let's also have a look at some of the applications specifically out of the automotive industry. So I'm bringing this up here now. Actually, when we are talking insights, right, this is where we are looking on how we acquire data, enrich data, right? But when we are looking also on creating insights and a value for our assets and increasing uptimes, alignment should always be mentioned. And then later on, we're going to see, because Gavin mentioned it, right? So we have electric vehicle companies entering the market. So we have also now different applications to cover. And this is where alignment will play a very important role. All right, now when we're looking at the application mix that you are facing in the automotive industry, right? There's a lot of different assets and applications. So what is the best technology to acquire further data from them and creating insights out of that data? So vibration, for example, is a modality that is great and can deliver huge insights. Then already data that is available to you today, right, from your SCADA systems, and now bring that in connection with the vibration data. But if you're looking on vibration, right, we all know there's all different kinds of sensors, handheld tools, wired sensors, online systems. And then there's also additional automation and control products available. So what is now the right tool of choice, right? So we have to make a choice. And where does that all start? By looking at the mix of applications. Because if you think about the applications itself, they are very dynamic and complex within the automotive industry. If you look down on the asset level, the assets themselves, there's pumps, there's fans, right? So a reliability engineer that's been doing this job for 20 years would say, yeah, it's a very simple asset, but the application makes it really special, right? And makes it more critical. And we're gonna see that there's different phases of criticality assigned to an asset. So let's have a look at the different applications and assets that we could basically monitor using, for example, vibration. Press shop, right? Coil unwind, scrap conveyors, a body press, right? Then at the body shop, elevator drives, transport systems. At the paint shop, we could look at the direct or belt-driven blowers, motor pump aggregates, or on the powertrain machine side, lifting systems that you could monitor. And then also in the main machine assembly, there's also test stands, right? And you would think, okay, why would I monitor a test stand, right? Because this is basically, I'm testing now my product. So why would I monitor the test stand? And there is a very specific reason for that. And you're gonna see that later on also in the applications that we are going through. So how now to make the right choice? What is the best tool to use to actually gain insights from my asset? So the first thing that you could do is, all right, I'm gonna look at my asset and distinguish, okay, is it more on the standard side or is it more on the complex side? And that is a very simple but effective way to first distinguish, okay, what type of technology when it comes down to vibration should I actually use? But it's definitely not enough. So then we wanna put next to that on how critical is the asset? So is it like, if we could look at criticality in different ways. For now, we look like how critical is the equipment itself, right? And then for that, if we span that matrix up, then we can decide, okay, I know now my mean time between failure, what is the cadence that I have to actually acquire data to create meaningful insights? Is every 4 weeks enough? Okay, I go with a handheld tool and some wireless sensors. Do I need a little bit more insights because there's gearboxes in there and I need a higher resolution? A data analyzer might be also coming in handy. The more critical we get, we want to be very, very close to any happening around the asset. So this is where we would have permanently installed online systems that can actually drive insights right at the edge. But as mentioned, this was just looking on criticality by equipment. But there's different phases to that. And it's also in terms of safety, right? How critical is this asset in terms of safety and secondary failure? And how production critical is it? Because there are assets in the automotive industry. If a full press line stops, the heart of your production basically stops, right? And then also quality. Think about a paint shop. You have a couple of vent fans. Yeah, it's a very simple asset. But if several of those vent fans are like actually deteriorating in their condition, that can have an impact on the quality later on. And then last but not least, as Gavin mentioned earlier, the impact on environment, right? When we're looking on environmental safety and governance topic. So when we're just looking at those vibration tools, right, there is a mix of modalities. And that is also what Gavin mentioned, right? A lot of companies just focus on one single product and try to rule all the assets with that. It's not going to work out. So there is different reasons there, right? And there's reasons based from a technology perspective, right? Where does it make sense to use which equipment based on the insights that I want to gather and how often? And then also from the economical perspective, right? A product mix is in a much more favor for enterprises. All right, let's now come to the applications, right? So one of my most favorite ones is the automotive press, basically. And we are operating here at that automotive press, right, with up to 20 cycles per minute. And we're looking here at automotive press line, like automated press lines. They are highly efficient in their forming process. Like when we're looking at a servo motor press line that is like really state of the art, mechanical transfer press and really designed for 24/7 production. So highest requirements on machine availability and reliability. And if you look on presses that are out there still, right? So transfer presses with an eccentric drive driven through a flywheel, a hydraulic press line. You might not see it that often any longer, but they are still out there. And then the state-of-the-art servo motor press line. And what is like, is it like really difficult now to really analyze that asset, or let's say the entire application? And what would we actually monitor there, right? What is a critical part? And that is basically, for example, for a transfer press with an eccentric drive, those are the eccentric shaft bearings. They are very, very critical. And as you can see here, this is actually where it requires an online condition monitoring that is connected to a SCADA system to actually combine data. But why? Why would we do that? Look at this. We have a very heavy loaded bearing that is running at a very relative low speed, right? So, and then bearing change results in a massive and really significant repair effort, because if you have to change a bearing on that specific transfer press, you got to stop that transfer press, so no production. So you have increased costs. And then why is it also, like, let's say, not such an easy task to really monitor that application is the signal overlap. Any one of you that has ever been standing next to a press, like the forces that are there at play when you're walking next to it, it's massive. And then you can think about a small vibration sensor, and then with all those forces at play, the impact is tremendous. And then those transfer presses with an eccentric drive, for example, right? They can also be a little bit more complex, right? So it can be a more complex drive where we have brakes, we have couplings, and all those components. So the more complex it gets, the more components that can have a failure are in there that can all lead to a significant repair effort and downtime, right? And again, the signal overlap is always present. But now think about, for example, here we have a bearing. It is possible to monitor those bearings and then also to really plan ahead your maintenance. So basically what we want to create, and that is like kind of the art in monitoring a press, right? And here it is really that we want to create repeatable measurements. Because think about, if you're measuring while the press is hitting, we have an overlap of signal, right? So, okay, I'm looking at that, but if I'm taking another measurement where the press is not hitting, what is now the benchmark here, right? So how can I observe, okay, when is my condition of the asset or parts of the asset deteriorating? And that is what actually makes it so special. And if we're looking at like a servo motor press, right, we have super dynamic servo motors. I mean, like, it's the beauty of the application itself, but it's very dynamic in their operational modes. And now we have like very extreme short cycle operating times that are somewhere in between 4 to 6 seconds. So that means the window where we can acquire meaningful data comes down to those 4 to 6 seconds. And that is very small. And there's, again, significant influences by shocks from the press technology. So how can we tackle that monster now? And it's basically, condition monitoring data by itself is not enough, right? So what we need then is also, okay, I need to understand, or maybe get information from a SCADA system, what is the crank angle, right? And maybe I can relate that crank angle now to my vibration readings to get the repeatability in the measurements, to get a clean signal that I can analyze. And that is the trick here. So we are taking the crank angle, then further zoom into our time and our time signal that we are acquiring through the sensors here. And then we can see, okay, where is the strokes? Where are the two strokes actually hitting, right? And then we can see the two shocks. And now that we understand and we can map basically those vibration readings to the operation cycle and the crank angle, this allows us to acquire repeatable measurements and to analyze all parts of that application. All right, let's go to the paint shop. So paint shop is the application. That's a lot of vent fans, right? And to be like really fair, right? And we mentioned that earlier, it's a very simple setup. It can be direct driven or very often belt driven. And the challenge here is like really a high impact on the product quality. So when the asset is deorientating or actually failing, then it can directly impact the quality. So what you could use here is wireless sensors would be sufficient, right? And then also like online condition monitoring system that are maybe not like measuring every second, but like also would go for like scheduled measurements. Here, we also want to have repeatable measurements so that we can actually predict the asset failure. And why do we want to do that? Think about something that Gavin is going to talk on later. By getting more information around the asset, right, out of the records of my asset management system, I can actually like really pinpoint out with all the acquired information from condition monitoring when is the ideal point, right, to do maintenance and repair activities on those assets with minimum interference of the production. And now let's talk about testing, right? We mentioned it earlier. So testing of brakes, right? So we have a lot of rolls, but that's what you see on the right bottom there. Or for example, testing motors. And motor and brake testing, right? The assets that you could monitor there are basically the driving motor for the test equipment. So that's like we're looking at the bearing and the motor. That's like in terms of condition monitoring, not like really fancy, but it's a super high dynamic application. Think about you want to try and do different speeds, right? So it's a dynamic application. You're going to receive high variations in your vibration readings, and you want to get repeatable measurements in the readings, right? So you want to kind of like identify different operation modes automatically and then basically pre-sort that data. That enables you to like really compare the testing of your asset and the equipment that actually drives the tested production output, and like really create comparable data there. So what we would need is an adaptable online condition monitoring system that has the capability to use something like operating state modes, and then also integrates process values like temperature, RPM, and so forth. When we're looking at electric vehicles, right, battery production is something that also has to take in consideration, right? The applications are also changing. Not everything is highly traditional. So when we have in the press section, we're having now this servo press technology. Then now when we're looking at electric vehicles, we have also battery production. When we're looking at coating, calendaring, the assets to monitor or let's say improve in this case. This is like really basically rolls, right? And it's like the challenge here is that a small asset deorientation has a very high impact on the product quality. And that is where you really want to ensure that the rolls are always aligned perfectly, right? And we're not like looking here at just getting a theodolite and try to align those. No, it needs like really high precision alignment. And what is the benefit of that, right? So if you would use high precision alignment here, then you can really minimize the downtime. So really minimize the downtime and tremendously increase the product quality. And then let's have a look at the application spindles. So spindles itself, specifically in the supply chain for the automotive, quite a common tool, right? So like hundreds, thousands of them. And a spindle is basically a bearing and a tool. It's not more what you would actually monitor there. But it's very high dynamic application, different speeds that are used. Sometimes it's also moving, right? And then also what you would get is the high variations in vibration readings. But it is possible to actually monitor and protect that asset and ensure that the quality of your product stays stable. So what you would use there is an adaptable online condition monitoring system that is also using operating states and then getting even process values in like position, right? Things that you might not be thinking of, right? RPM, temperature, and creating a relation. And then we take this acquired data and now we have to think about, we already start enriching it at the edge close to the asset by combining this data. We are creating our first insights, and now we want to further enrich that. Remember, condition monitoring data by itself is incomplete. And basically, we want to know the asset history. And this is where the magic happens, by combining those two sets of information that will help us to transform findings into actions. And this is where I pass it over to Gavin again.
Thanks, Chris. So as Chris was kind of saying there, so we have all that data, and so how do we make that connection? How do we make that connection from the condition-based to utilization of a solution then to make better decisions based on that? And this is really where the EAM, the CMMS comes into it. Next slide, Chris. Oh, sorry, yeah. So the real power of connect reliability, sorry, go back a slide. The real power of connect reliability is when you then connect the team to it. So, we can unlock team capacity in several ways. First, we can make that asset condition data accessible to the different team members where they can make those better decisions. Automating work order creation. So that could be whereby, we let's say set up a workflow in the system to notify us if a reading goes above or below a certain threshold, and that can then generate the work order, include any parts that might be needed to complete that work, and then we can schedule it and include any work instructions necessary. And then third, so we also provide on-site or over the phone expertise support where that's needed. Next slide. Next slide. Perfect, thanks. So how do we act on that data? So utilizing the previous slide, sorry. So how do we act on that data? So utilizing our CMS, our enterprise asset management software, and then enabling engineers, technicians on mobile devices to then execute that work. So within the CMMS, the EAM, you'll be able to see those trends on a live dashboard, a live report, and set up relevant notifications that if a reading goes above or below a certain threshold on a critical asset, that can then notify the relevant team members and also potentially create a work order off the back of that. Set up for that planned maintenance, that work can be all the relevant parts needed, the relevant work instructions. That work can then be assigned out, and then the engineer, the technician can take action and then complete that. That can all be managed digitally, paperlessly through the CMMS and Fluke Mobile, the mobile device. Next slide. So many of our customers do have similar workflows in place, but usually with multiple vendors involved, which does increase the level of complexity, integrating different systems with one another, and also cost. So there are multiple connected workflows here between vibration analysis, alignment, and EMAINT. But then when we also add in mobility, automated diagnostics, expert services that that we provide, and you can start to see how this can make a compelling case for standardizing. So really, this would be a kind of a typical connected workflow where monitoring vibration, whether it's through continuous monitoring, periodic, or whether it's let's say an operator, an engineer doing a walk around, collecting data as they go, and then through the reporting, we can then analyze that data, and they can notice any trends, any abnormalities with that. Using that data, then they can then create a work order, and then to fix that issue and assign that out to the relevant team member to complete. Then they can perform the relevant preventative corrective action. So whether it's replacing a bearing, a seal, realigning the equipment, rebalancing, and then attaching the PDF to close out the work order. So this is where you can really start to see the power of combining different solutions together. Another solution, one of our connectors, which Chris was speaking about earlier around, connecting your SCADA, your PLC systems. So connect to assets, which has the ability as a connector to pull data from your SCADA, your PLC, your BMS system, and input that directly into our CMMS platform, eMaint, for similar purposes in terms of work order creation, but also providing us more insight on that data, where we can collect a series of readings over a period of time and see the trends, where have issues been highlighted in the past, and create work orders to, again, assign out to the relevant team members to complete. So just means that we're acting quicker, making better decisions based on the data that's available to us. Next slide. This is one of our case studies, one of our automotive customers, Dana. They've been a customer for a very long time, so a worldwide supplier of powertrain components. So they were facing some challenges, mainly around minimizing their critical equipment downtime, especially on some of their key assets, highlighting equipment improvements, but also as a business an emphasis to expand their reliability program and utilizing connected tools and sensors. So as mentioned, they've been an eMaint customer for a very long time, and they managed to incorporate power monitoring, thermal imaging sensors, and temperature sensors. All that data connected via Fluke Connect directly into eMaint, providing their team with real-time access to data, and then so that enabling them to make better decisions based on that information, and reducing the amount of downtime on some of their critical assets. So TPM, so total productive maintenance, one of the main strategies in the automotive industry. So as you can see there, a very holistic approach in terms of maximizing equipment effectiveness. There are 8 pillars, and some of the key areas that I suppose a CMMS EAM can enable it. One way is through operator inspections. So a CMMS can automate inspections, so moving operators away from paper-based manual methods to complete those inspections. So this helps with streamlining those daily walk-around tasks and providing a digital and reportable record of completion for those inspections. So any issue found during an operator inspection can automatically generate a corrective work order, allowing the teams to better schedule maintenance, track repeat issues, and then provide visibility into the corrective action to take to address the problem. A CMMS or an EAM also provides a centralized platform to manage that equipment, so you can manage all of your tasks, asset health data, maintenance schedules, and historical data. So by tracking all this information, a CMMS can help the maintenance team identify potential areas for improvement, but also, as Chris mentioned earlier, this is the shift from a more proactive approach rather than corrective to maintenance management. And this results in increased equipment reliability and also productivity. Planned maintenance. So CMMS also simplifies creating planned maintenance schedules, assigning tasks, and generating maintenance work orders. And this thereby, maximizes productivity, consistency, and equipment lifespan. And then finally, OEE. So OEE, overall equipment effectiveness, which measures the percentage of manufacturing time spent producing defect-free products. So how a CMMS, I suppose, enables this is that it captures real-time data on equipment downtime, production losses, and performance metrics. So this enables businesses to easily and accurately measure and analyze OEE. Next slide. So IATF, which is, as I'm sure many of you are aware, an essential requirement for all automotive and manufacturers and suppliers. So there are really 4 different areas that a CMMS and an EAM helps with compliance in this regard. So first of all, preventive predictive maintenance. A CMMS enables organizations to schedule and track routine PM tasks, inspections, and calibration activities, as well as standardizing maintenance procedures across the board, whether it be for a single plant or standardizing across multiple locations globally. Risk management, so identifying and managing risks, is crucial to preventing potential failures and faulty products, as well as ensuring worker safety. So a CMMS really helps with certification tracking on personnel that are executing work. Corrective and preventive actions, so a CMMS really facilitates the implementation of these processes required by IATF to assign responsibility, track corrective actions, but also ensure timely completion of those tasks. And then finally, document control and record keeping. So I suppose a CMMS is your one-stop shop for tracking all your tasks, your records, your SOPs, operators checklists, any other relevant documentation which can be associated with your assets, your work orders, spare parts. And this ensures easy access, version control, and traceability of that documentation, which is crucial for easily passing IATF compliance audits. Next slide. So just highlighting, I know we've kind of covered a few of these. So the benefits of a CMS EAM. So extending the life of your critical assets, helping companies to meet those compliance and safety standards, as we saw with, in particular, IATF, but also, quality ISO 9001, improving work completion rates. So, through more data and more easily accessible data, making quicker and better decisions, moving away from manual processes around, managing work through paper and Excel, and with a digital solution, helping companies reduce those maintenance costs and making data-driven decisions based on that information. And most importantly, reducing equipment downtime. So reducing the downtime of those critical assets by more easily accessible data where you can then make better decisions. Next slide. And this really speaks to that standardization piece. So I suppose with our solution, having all of your data from a site-by-site perspective within one account, within one platform, where you can, compare work completion rates across different locations, standardize operations, which gives, I suppose, from a corporate perspective, better visibility into how plants are doing, where there might be gaps, areas to improve, but also making compliance easier as well. And then from a condition monitoring perspective, seeing machine failures and automating those work-based triggers. Next slide. So connected knowledge, this is where where we address and bridge that gap in terms of skills and knowledge. So we are heavily invested in customer success. We do everything from training up your people on how to use our different solutions. We provide, consultations on best practices from a reliability perspective, whether that's over the phone or coming to site to help with the complexity of some of these tasks. So our experts, do teach some of the most advanced ISO level courses in the world. So we not only, I guess the point is, we not only sell the tools and software you need for a successful reliability program, but we also are there with you as a partner on that journey, and to make sure that you are successful with that program. So kind of helping you to bridge that gap, as we saw earlier in one of the kind of the common trends that's that we've seen in the industry. And now over to you, Chris.
All right, and basically what that does, it basically shortens the time to value for you, right? So whether that is like at the beginning, helping you making the right choices, right? So that is based on technology, also helping you assess what is available today, right? So what a lot of people forget is like looking for that one, let's say, single holy grail solution without starting. It's like, what is already there, right? And how connected can that basically be? So for example, if you're looking on SCADA system, like for example, Gavin was showing something that is called connect to assets, right? So this is where you have already something existing that you then can implement. This is then the next step where this, let's say, kind of knowledge and skill gap can also the pillar of connected knowledge services can like also help with the implementation, right? Again, shorten the time to value by implementing it like scheduled and fast. And then also like, if you don't have the capabilities for analysis and reporting in-house, then you can also outsource that, right? Or think about data management. There's a lot of companies that are also saying like, okay, we understand that reliability and let's say all the data included is getting more and more and more, and that infrastructure is very, very difficult to handle. So data management, like also that can also be a service, right? So there's a lot of companies that are also looking towards that. And then also others, they have like, okay, we have like, for example, we can do the data management, fine. We can do a certain kind of analysis also by ourselves, but there might be a need for an expert on demand, right? So when the demand is basically outweighing your supply that you basically have there, right? Then you can bring in experts on demand that give you mentoring on your data set, that can also like train you, can also provide corrective field services, etc. And if you look on that, like how does that work again, right? So first of all, how would you start your entire journey? So you're always questioning yourself, okay, what you should do always is like take a step back and ask yourself, what does great look like? Then you need to go, okay, let's do site assessment, and then afterwards, after the assessment, do a solution engineering. Okay, so we have identified what is my asset monitoring plan, right? Think at the beginning when we were opening up the presentation, it's like, what would be the right technology to actually use? Maybe you have also like already like certain technologies that come with the that are provided by the OEM of the equipment that can be used and integrated and used together with other technologies. And afterwards, bringing the data, and that's like where we are creating insights. That was something that Gavin was mentioned earlier, right? So that there is like algorithms for automated analysis, right? And then this is backed up by experts, right? By experts that understand assets, that experts that like really have interfered with assets, and then can also pressure test what algorithms are doing today. And then like that sounds all like very, very, very automated. And yes, it is to like a very certain extent. But also manual data collection is not excluded from that. So that's like, and you can do this like both ways. If you do like the condition monitoring part, collecting the data, and then send it to the data management part. Or for example, you take a mobile app and enter your data so that it gets directly posted into your CMMS. So those remote services basically are like then an active assistance, right? So where you, with that model, so connected reliability, you are basically stabilizing your entire reliability journey. So while you are like very stable and like you have a really, really good reliability team today, think about what might happen in 3 to 4 years from now, right? So you might have, you might face certain retention of your staff, right? And suddenly the skill gap is there. Once you have applied the framework of connected reliability, at any point in time, you can think about that. You can take one of those pillars and just plug them in, because you have taken that one step back and looked at the entire framework rather than just one single silo and one single technology. And with that, we end our presentation. We thank you very much for your attention, and keep it open for question now. All right. That was stop screen sharing, right, Gavin? And then let me see.
Yep.
The questions. I just have like a very tiny window here where I just see a single line. Let me see if I can pop that up. Okay, I see it now. All right. And we have a question to send further information. We can do that. Let me start here. Okay, so we have Selvin. Is there a difference between a CMMS and an EAM in the present industry, Gavin?
It's a good question. So I suppose the best way to answer is, there is a lot of crossover. So all EAMs can do what a CMMS does, but not all CMMS can do what an EAM does. So I suppose a CMMS is really used to, manage the maintenance of equipment and, machinery, whereas an EAM is more, it takes a more holistic view of asset lifecycle management. So it brings in various other departments around, operations, finance, planning, procurement, whereas a CMMS is really more focused on, task completion, work order execution, and the utilization of spare parts with that. So I suppose to kind of sum it up, EAM just, it really is more geared towards, the holistic, view of a business rather than just in a couple of different departments.
All right, good. Then the next question, maybe I take that one. So normally when a factory or service center is considered, there will be machines like a paint booth system that is supplied by the OEM, and they already have embedded software to monitor their assets. How can FRS devices prove a pivotal solution provider compared to such a scenario? If possible, please highlight case studies related to wireless sensors like the Fluke 3563 as per the information received. And from my understanding, the Fluke 3563 wireless sensors does not work for variable frequency drive motors. So let me just see how can the device prove a pivotal solution provider scenario. Okay, so in case, and let's maybe start with your first question, where you have an OEM that provides you already with a monitoring solution, right? And there you can basically see, I would say it kind of depends, right, what you can do here. If there is a connectivity existing on that OEM module, then you can integrate it into, for example, like email, CMMS, and make that connection happening, right? If it's just a couple of sensors and there are certain outputs, then you could use an FRS device and plug it on there. You could, for example, use, if there's a SCADA system existing, you could use, and that is what Gavin showed earlier, you can use connect to assets, right? So that is what we were mentioning earlier, is that like you can use what is there already, right? So it's not that you go in there, let's just scrap all and everything and we just plug in whatever is needed now. No, you really have to assess what is there, and I believe that is a really great question. So in order to like take a deep dive, if that is possible with that type of equipment in general, I would say yes, there can be an integration, but we would like further assess. So the question was from Nisha. Please reach out to one of us and we provide you with the right contacts, and then we can have a look at that if that scenario can be covered for you. Then the next question was, so then adding on that question was around wireless sensors and variable frequency drives. It's a very good question. For variable frequency drives, think about like when we would talk about the servo motors, right? You have like so fast changing speeds, right, that you need to actively, like really actively measure RPM. So you need like really a signal so that you can see like how the RPM changes over time, because you want to do something like order tracking as well, right? Which we all know is like needs an active RPM measurement. So if you have a variable frequency drive with high fluctuations, then a wireless sensor is something that I would not use. Right, so that means this is where the mix of modalities comes in, right? So what is the right tool here, the right tool of choice? Is it an online system or is it a wireless sensor? Then there is like certain fluctuations a wireless sensor can handle, right? Where, for example, you would take, if you have a fluctuation of 100 RPM every now and then, right? That is something that can be covered, that also algorithms can like take in consideration those fluctuations, right? Yeah, that would be my answer to that. All right. We have a Dodge vibration sensor. Can that be integrated with eMain Fluke? I would say maybe provide us further information. I don't know what type of vibration sensor that is. Maybe Gavin, you have heard anything about that?
I have not heard of that one in particular, but I would say that we are able to connect with a number of third-party systems, third-party sensors. The question is just around, I suppose, the kind of the back end Are there APIs in play? If so, that would be preferable. But as Chris said, yeah, we just need a little bit more information around that.
All right. Let me just see for the I believe that was it. Yeah, we are through the questions. If you have any more questions, right, please do not hesitate to contact us directly as well. And yeah, so Nisha is going to share. Okay, cool. Yeah.
All right. Christian and Gavin, thank you so much for your time today. We appreciate you taking the time to speak with all of us. For those in attendance, when you exit the webinar, you'll see a very brief survey. We'd ask that you take that survey to help us to continue to provide strong content like you received today. Thank you everyone today for attending. Again, Christian and Gavin, thank you for your time, and we'll see everyone for the next Fluke Best Practices webinar. Thank you, everyone.
All right. Thank you.
Thanks, folks.